Hello and welcome. My name's Anthony. I'm with SEMplicity. Today I'm bringing you Vector Search 101. This is going to be the first of many videos on Elasticsearch on this channel. I'm going to be bringing you through the basics. What is vector search? Why should we care? Into how do we get a model from Hugging Face into Elasticsearch? And then also how do we use those models embeddings in our cluster? So you will need a cluster that's at least 8.0 and above to follow this. That's when this feature came out. I will be on ESS, but you could also be on-prem ECK, I believe. I do have a guide to go with this video. This is going to be going in deeper in depth in this topic. So yeah, this will be available for download either in the description or in the comments. So get ready. We are going to start with the fundamentals. So what is a vector and why should we care? Imagine every word in our dictionary, in our lexicon, is in this space, is in this world. And in this world, you have these points or addresses or whatever you want to call it. These points in our solar system, in our world. You know, maybe here it's this is king. That's a word. Maybe here is dog. Maybe here is bagel, or some other word. So these words, why they're important to computer science, why they're important to NLP, is that this allows computers or models to better understand words not just as this string of characters, but also have meaning behind it. So where that comes in is that in this world, their neighbors are going to be words that are similar. So, something that might be near king is queen. Or maybe prince is over here. And, a little ways away, we have dog, and maybe around here we have cat. Maybe over here we have, I don't know, chew toy or something. Something like that. The idea is that these words are like their neighbors. And then, over here we have rutabaga, or, some unrelated word, not king, not queen, not dog, not cat. Each one of these points have these addresses in these many, many, many dimensional spaces. Really, I just drew this two-dimensional space just for simplicity's sake. But in reality, these models have them in hundreds of dimensions, in this world. This world is hundreds of dimensions. And that allows, like I was saying, computers to better understand these words. And they have them in these vectors. That's where vector search comes in. So this king might be 1, 2, 3, 27, ... And then dog might be some other address. It might be 2, 3, ... Some other vector. So what we're going to be doing today is we're going to be taking this, or what it means, whatever our model's trying to do. Typically it's a vector. And we are going to be putting that into an Elasticsearch index that we can then use to kind of query. So before, if we were doing before vector search came out, before dense vectors were a thing, if I wanted to do a match for the word king, only documents with king specifically, came up. It had to be written in the document as king. Now, what if a user searched for king, but they also want stuff for queen? What if they also want documents with prince to come up? What if I don't want to specifically say king? Well, then that's what we're trying to do today. So in the context of Elasticsearch, instead of having to explicitly define, okay, this is our string, only match things in our inverted index, as king, hey, give me words that have similar meaning. That's the whole idea. That we're increasing our recall by saying, give me all you got, even words that have meaning near it. The same thing with dog, cat, or chew. If I, type in dog, maybe I also want things general for all pets, or if something related to cat as well. Come on, add that to the list. So with named entity recognition, it's going to look a little bit different. So really, the model is using these vectors to label each of these guys as something. So so instead of dog, cat, king, queen, and these vectors, we're going to be focused on persons and labeling persons and places, which can also be represented as vectors. So at the end of the day, I want in my documents I have the name Anthony. I spelled my own name there. I want the model to say, okay, I know that's a name. Or I have Kentucky. I want the model to know, using vectors, okay, that is a location. That is the example that we're using today. Like I said before, there are tons and tons of different use cases about vector search. This is really just the tip of the iceberg and the basics. So that's what we're going to be doing today. So yeah, those are the basics. So let's go down here and see what we need to get a model from Hugging Face into Elasticsearch. So I chose this NER model. This was used in a couple of Elasticsearch blogs. Really, the commands and the stuff that I'm showing today are going to be, kind of Frankenstein from that. So this model, like I said, is an NER model. It should be doing this. My name is Sarah and I live in London. Oh, look, Sarah's a person. Oh, look, London's location. So in order to do that, first we need to pick out our model. I picked that out already. Then we need to have at least one ML node in our cluster. If you are on Elastic Cloud, it is very, very easy to do so. I'm cutting this out. So you're going to go to your deployment page. You're going to click edit here, and you just need to make sure that in this section, the machine learning indices section, I can't talk today. I think you can get away with 1. I have 8 for some reason, but as long as you have this activated, you can participate in this NLP revolution. So we have this, that's good. We also need Python 3 downloaded somewhere on your computer. We're going to be using the eland library in order to do this. So with that, you need Python. And then we need a user with at least these permissions. So you need one of these, this monitor ML or manage ML, and or monitor, manage, or all. So you need one from this and then one from this. I have a user already in called NLP user. So that is what I'm going to be using today. And then in terms of what libraries and commands we need to run, we need pip. We need to do a little pip3 install torch 1.11. So I already have this. I am, if you want, make sure you're in a virtual environment. I'm not going to go over that. But yeah, make sure that you have exactly torch 1.11. This is what the documentation says. Make sure you also have the eland library. So pip3 install eland. I have it all already. If you are on an M1 Mac, eland or PyTorch, I forget which one, will give you a problem since you don't have a Rust compiler by default. So you just need to run this command, and then both, whichever one was giving you a problem will solve it. And then to actually use the model, this is what every importing eland function is going to look like. So we're going to have our eland import hub model. If you want to check that the other 2 installs were correct, eland import hub model -- version. Let's see if this works. As long as this gives you something, then you know that you imported it correctly. The the torch and the eland were, that's all fine and dandy. So what we need is we need our URL. So we need our this string. So this endpoint we're going to get from. Oops, sorry. Cut this part out, cut this part out, cut this part out. So the URL we're going to be getting from here, this Elasticsearch endpoint, how it goes is https // this is our username and this is my password. I will be deleting the cluster after this, so this password will be void. Our hub model ID is going to be from here, this ID. So elastic/distillbird ... Our ES model ID, this is something that we are going to make up. So this can be anything you want. I just said NER example. Make sure that you remember this name because it is going to, come in handy when we write our pipeline later. And then you have to define your task type. So there's, I think, a dozen or so task types. It will not work if you choose, let's say if I wrote, zero shot here. That's another use case. It won't work. So make sure that you correctly label your model. And I have here, this is just what all the different flags and stuff that you can add. I think there are other ways to authenticate as opposed to a username and password. I have that linked here. And then this is what a successful message should look like. And then what we are going to do to synchronize and make sure we actually have it is we're going to go to home. We're going to go to analytics, machine learning. We're going to go down to model management, train models. And then somewhere here we should see NER example, or actually I lied. There's going to be a pop-up that looks like this that says synchronize saved objects because I already have NER example in. I'm too lazy to show a live example. So we are going to just hit synchronize down there. And then once it is synchronized, we are going to hit these three dots right here. We're going to start deployment. We're going to have everything as, sorry about that. We're going to have everything, as the default. You can, choose different, because I already have NER example in the cluster, it's not going to work for me. So I am deploying, really I'm deploying a second model. And that's what you need to do in order to actually use it. So you have to do those two steps first. So then we should have the model in Elasticsearch. We should be good to go. So now, in order to kind of check if it's working, so we're going to go down to DevTools. And we're going to run this train modeled NER example deploy infer. So this is inferring something from our model. So this could be, show us the vectors, show us the, whatever we're trying to infer, whatever the model is trying to output, this is what we want. So this is what we want eventually to be in our indices. So again, my text field is, hi, my name is Anthony and I live in Kentucky, which is true. The model did what it was supposed to do. It's, it saw Anthony was a person and Kentucky was a place. Wonderful. You have some other things like how, confident the model is, stuff like that. I think you could expand this to other things. Maybe it can recognize, okay, Anthony ate an apple. Oh, apple's a fruit, apple's a food, something like that. Those are, some of the other things that you could maybe do with this. But this is only working after we run this _ml train models NER example, this long command. We really can't use this in a search. So that is why we're going to be doing the next step, which is putting it in an actual index. So like I have here, we're going to add inferences. So that's what this is. This is an inference from ML models to Elasticsearch documents. So what we are going to do is we're going to go to home. We're going to go down here to upload a file. I'm going to select my file. This is the entire script of the Broadway show Les Mis. I personally was not a fan of it when I saw it. So this is the entire file contents of Les Mis. We have line, paragraph, and then the timestamp. Those are the only 3 fields. So we are going to import here. Then what I'm going to do is I'm going to go to advanced. My index name is going to be NER example. And the number of shards should be already there for you. The mapping should be already there for you. What we're going to do is we're going to take this, this pipeline. I'm going to put myself in the middle there. We're going to take this pipeline from, I kind of stole this from a blog. And what we're going to do is we're going to paste this here. So this is ingesting all the documents that we got from Les Mis using this pipeline. So because of the syntax, we don't need that put there. This is the bread and butter. This is what you're going to use on pretty much all ML model pipelines. This is the inference model. So again, it is basically just running the command that we did earlier where you saw, okay, Anthony is a person. We're going to be running that on a specific field in our document. So in this, the lines or the stage instructions, those are that's a paragraph. That's what the field is called. And here, this is basically saying in the model, somewhere in the model, it's saying we are going to analyze text field. So it's saying pretend that paragraph is text field in the model. This is the target field that we're going to be putting everything in. So all of everything that you saw there, the classification of the people and locations is going to be in our documents as ml.ner. And our model ID is something that we defined in our, up here, if you remember, in our ES model ID. So that's where that's coming from. And then everything should be wonderful now. We should have no errors. We should actually be able to see stuff in our index. So we have NER example. I'm going to just search this, and we should be seeing stuff. So it has our paragraph. This is some line in the movie or the play, and it knows. Okay, Bourgard. I'm horrible at pronouncing French. Sometimes it doesn't get stuff right. Like here, it said the dash was a location. Maybe that fits in it somewhere. But okay, it knows Perriot is a person, it knows Milla is a person, Orpha, these are all characters in Les Mis. And that's what we wanted it to do. So it enriched our documents in NER example with the thing that we wanted. So in this case, it was NER's person in place recognition. So that's awesome. And yeah, it's in ml.ner entities, and that's wonderful. So again, just to review what we did. So we went over the basics of what is a vector space, why should we care about it, why is it used in search. We went over how to download the model via the eLand library from Hugging Face. If you want me to go over the other kinds of importing methods, leave a comment. And then what we did was we set up the ingest pipeline in order to actually enrich our documents with with the thing that we wanted from the model. So that's great. I also have in this document a bunch of different use cases. These are either parts of documentation or blogs that have anything I could find really of the dozen or so use cases. So we just went over NER. The more popular ones are probably text similarity, text embedding. Text classification is something for like, okay, if I wanted to classify this tweet or paragraph or text as positive, negative, or neutral sentiment, that's what you'd use for that. Question and answering, this is more ChatGPT type stuff. I also, on that note, I want to make another video about Elser, so drop a follow, drop a subscribe if you want to see something like that and get notified. Thank you so much. Have a good one, and thank you for watching.